Hello scholars, welcome to the number jungle. So today we're going to be looking at the 3D number jungle. It's poppin'. So we are going to be working on contour diagrams, which are a way of representing 3 space on a page so that it's a whole lot less confusing. It's a great way to visualize what's going on a graph. Now, the problem though is that it's sometimes difficult to tell graphs apart because we're not used to this sort of way of looking at the world. So a way to help that out is to try to match up some contour diagrams and see how they look next to their respective graphs. So we have these 4 right here, and let's just go down the line. Now, A is f of xy plus x plus y. F of xy equals x plus y, and g of xy is x minus y. So I can visualize this as two separate graphs, one where z is increasing as x increases, and z is also increasing as y increases, and the other where z is increasing as x increases and decreasing as y increases. So it would have to look something like this. Now, we actually have one of those right here, 2. And it looks like B is of a fairly similar shape to A. Now, what makes them distinct to me is the values before the x and the values before the y. Now, x plus y is going to be increasing at a very straightforward rate. I would say that it would be growing at about a 45-degree angle respective to the origin. And in this case, that resembles 4 best. So I'm going to say that A is 4. Now, when we have to distinguish between F and G in the graphs, I'm going to say that since it seems that as the value is going to be increasing as x increases, there's going to be something along the lines of this with respect to x, and there's going to be something along the lines of this with respect to y. Now, this is going to turn into one line because it's one plane, and I believe that that compilation will look like this, as is shown right here. So I believe that these lines here describe f of x. Well, these lines right here will describe g. Now let's move on to the next one. Just as we did before, we can see that that as x increases, z is going to increase, and as y increases, z is also going to increase. So similarly, these are going to be representing f, and these are going to be representing g. Now let's move to the trickier ones. So in this case, what I like to look at is the ln, because that's what sticks out among all of these. It's possible to confuse x squared minus y with x squared minus y squared when I'm looking at the contour diagrams, but ln of x is very distinct. Now, what we know is that ln of 0 is not possible, so we should look for a place where there's a lot of activity going on right in this line or in this line. Now, if we look at 3, we see absolutely no activity along the y-axis. It appears with the contour diagram that it's going to be remaining relatively the same value along that line. So that is going to rule out 3. 1, on the other hand, if we look at it, we see these huge dips all over the place, and those to me suggest that there is a great increase or decrease in value. Unfortunately, with contour diagrams, unless they're labeled, it's not possible to tell if it's an increase or decrease, but that doesn't matter in this case. So we can see that C is going to be going with 1, and from the looks of it, from these peaks all along the y-axis, these horizontal curves are going to be representing G, while the more vertical curves are going to be representing F. That brings us to 3. Now, if we look at 3, we can see that there are 2 separate curves. There's one that goes like this, and I'll draw the other one down here just for clarity, and there's one that goes like this. Now these can be a little bit difficult to tell apart because they both have some similar curvature, but what I like to go by is looking at the equation itself. I happen to know that f of xy equals x squared minus y squared is going to be a hyperbolic paraboloid, and that looks something like this in a contour diagram. So the key right here is just to find the one that most resembles that, and in this case it's going to be these ones that I drew on the top, which are going to represent F, and then by process of elimination, g of xy equals xy is going to be the ones that are represented on the bottom. So I hope you've gotten a better idea of how contour diagrams work. For me, it's all about finding the points that really express what the graph is. That tells me the most. And sometimes it's good to look at the equation before you even think about the graph. I hope I've been a good guide through this number jungle. Almost got bit by some pumas there.